Introduction and Chemistry 20 Review, Naming Organics. This goes along with the BR20 assignment. Rules for naming complex organic molecules. Well, pretty complex for us anyway. You want to take a look inside your handout. These notes are inside of your handout, so just make sure that you know where they're located so you can reference it as you work through the assignment. So number one, we always locate the longest chain of carbons. This is the molecule's backbone and determines the organic prefix that is to be used from the data table. And believe you me, I have been as tricky as I possibly can be, so the longest chain will bend around corners. It's up to us to try and determine what is the longest string of carbons holding hands in that molecule. After we've determined the longest chain, we have to start numbering the carbons in the longest chain. And that means we got to start from one end or the other. Now, we always start from the end that is closest to the alcohol. If it's a tie, then, or if there is no alcohol group present, then that means we're going to have to start counting from the end that is closest to the double or triple bond. And if that's a tie, or there is no double or triple bond, we start from the end that is closest to any alkyl group. Remember, an alkyl group is an additional carbon group, a smaller carbon chain. Third, you name the parent chain. That's your longest chain of carbons. And then you're going to list your alkyl groups. That's ethyl, methyl, propyl at the very front of the name. And it goes in alphabetically. Remember, that's not counting covalent prefix. So it's always ethyls, then methyls, then propyls. Even if you have a dimethyl, it doesn't move it before ethyl. Ethyl is listed first, then methyl, then propyl. Then you list your double bonds right after that parent chain. And then you list your alcohols at the very end of the name. Now remember, you need a covalent prefix if there is more than one of any of these groups. 2 alcohols has to be diol. 3 double bonds has to be triene. A number for each alkyl group then has to be added, and for each double bond and for each alcohol, so that we know where the location of these special groups are on our long carbon chain. So inside your notes, I have given you a generic outline for what a complex organic molecule looks like, the order that everything is placed in. If we have small carbon chains, they come first. They're listed alphabetically, and there's a number that precedes each one of them to tell us where on that long carbon chain they will be located. Right after our alkyl groups, we have the name of the parent chain. That's the longest chain of carbons. If there is a double bond, we have ENE right after that parent chain. And the number that tells us where the double bonds are located comes at the very front of the parent chain. Now, that's also where the number for the alcohol goes, if we have no double bond. So again, alcohol always comes at the very, very end. And the number for the alcohol comes right before the parent chain. But if there is a double bond and an alcohol, the double bond number will go in this location, and then the alcohol number will be moved right before the OL ending. Example 1. First, locate the longest chain of carbons. And I'm sure if you look at this, you see 1, 2, 3, 4, 5, 6, and that would be wrong because it has to be the longest chain of carbons holding hands. If I lasso these guys, which I want you guys to do on your paper, if I lasso these, those carbons are all bonded to one another. That is the longest chain of carbons I can find holding hands. Now I have to number those guys starting from the end closest to the alcohol. And if that's not present or it's a tie, then the double triple bond. If that's not present or it's a tie, then I go to the alkyl group. But I do see I have 2 alcohols. I have 1 here and 1 here. I don't have anything else to worry about inside this molecule because I don't see any double bonds or alkyl groups after I circle that longest chain. So do I start counting from the left-hand side or the right-hand side? Well, if I start from the left-hand side, that means the alcohol closest to that end is on the second carbon. If I count from the opposite end, that means that alcohol is also on the second carbon. So it's a tie and it really doesn't matter. So in my notes, I'm going to circle the two OHs, and I'm going to number my carbons from the left, 1, 2, 3, 4, 5, 6, 7, 8. So your notes should look just like this. Now I'm going to name the parent chain. That's the longest chain of carbons. I have 8 carbons singly bonded. 8 carbons is oct, singly bonded is ane. So I'm going to write octane. And then I list my alkyl groups, of which I have none. Then I list my double bonds after the parent chain, of which I have none. And then I list the alcohols at the very end of the name, and I have 2 of those. I need a covalent prefix because there's 2, so I call it diol. And then I need a number at the very front of the parent chain to say where these alcohols are located, and they're on the 2nd and 7th carbon. So right before oct, I write 2, 7 dash. So this guy is called 2, 7 dash octane diol. Box it. Moving on. Example 2. The first thing I do is locate the longest chain of carbons. And that's easy because I can see a long chain running right through here. Now I have to figure out which end do I start numbering from. Well, inside my chain, the things that I have to include, the things that are present aside from just our longest carbon chain, is a double bond and 2 methyl groups. So I start numbering from the end closest to the alcohol, and we don't have any of those. I can number from the end then closest to the double bond, and that's a tie because the double bond is right in the middle. So if I started counting from the left-hand side, that would be on the 3rd carbon. If I started counting from the right-hand side, it'd be on the 3rd carbon. It's a tie, so that means I move on to my end that is closest to an alkyl group. Well, the alkyl group on the left-hand side is on the 2nd carbon, and if I count from the right-hand side, this methyl group would be on the 3rd carbon. So since 2nd is smaller than 3rd, that means I'm going to start counting from this end, which will put the methyl group on the 2nd carbon. Now to name it, I name the parent chain. The longest chain is 6, which is hex. Then I list my alkyl groups at the front. I have 2 alkyl groups. So a 1 carbon chain is called methyl. 2 1 carbon chains would be dimethyl. And I have to include numbers before that that tell us where the methyl groups are located. And the methyl groups are on the 2nd and 4th carbon. So I put in 2, 4 with a dash. Now I have to list my double bonds. And I have a double bond, so I have to put ene in the name, and it is located on the 3rd carbon. So I put in dash 3 dash. Now note that between every number and letter, I have put a dash in the name. And when I have consecutive numbers, I have to make sure there's a comma between each number. So this molecule is called 2,4-dimethyl-3-hexane. We start by locating the longest chain of carbons. And if you said that's 3, that would be correct. And then I have to start numbering the carbons, starting from the end closest to the alcohol, and I don't have one of those. So I'll start from the end closest to the double triple bond, and I do have one of those. So I will number my carbons 1, 2, 3, starting from the left-hand side. Now I write the name of the parent chain. 3 carbons is called prop. And then I have to list my alkyl groups. I don't have any of those. So I list my double bonds, and I do have one of those. So double bond is an ENE. So after prop, I'll put ENE. So that gives me propene. And that is on the 1st carbon. So if you have 1 propene, that is wrong. Now, why is that wrong? It's because the 1 is considered redundant. We don't need it. Now, what do you mean we don't need a number? Well, this is the question we were given. And I guess the double bond could go between the 2nd and 3rd carbon, and it would look like this. But then, according to my rules, I would have to start counting from the right-hand side because I always start counting from the end closest to the double bond in a situation like propene. In which case, I move that bond, but it's still on the first carbon. So the double bond can't be on the second carbon. It can only be on the first carbon. Now to further prove my point, I'm going to use the magic of PowerPoint to rotate the molecule on the right-hand side. And when I do that, we see it is identical to the one on the left. So whether I put it between the first and second carbon or second and third carbon, it's the exact same molecule, and the double bond is on the first carbon. So the answer is simply just propene. So let's locate the longest chain of carbons. Give it a good look over. If you said 5, that would be wrong, because if I bend around the corner here, that would give me 6 carbons. So 6 is my longest chain. So now I have to start numbering carbons from the end closest to the alcohol, or if not present, the double bond. If not that, then the alkyl group. So what do we have in this molecule? I have a methyl group and I have a double bond. So since there are no alcohols, I will have to start counting from the end closest to the double bond, which means that this would be my first carbon because the double bond is closer to that end of the chain. Then I'll number the rest, 2, 3, 4, 5, 6. Now name the parent chain. 6 carbons is hex. Now I list my alkyl groups. Well, I've got a methyl group, so that goes right at the front, methyl, and that is located on the 4th carbon. So single carbon on the 4th carbon. And then my double bonds, I do have a double bond, so hex has to end in -ene, and that double bond is on the 2nd carbon. Now that I have dealt with everything that is in the diagram, my final answer is 4-methyl 2-hexene. Last example. Locate the longest chain, and I count 1, 2, 3, 4, 5, 6, 7, 8 carbons if I bend around this way. Now I start numbering from the end closest to, well, let's see what we have in this molecule. We have 2 alcohols and we have an ethyl group. So I start from the end closest to the alcohol. And if I start from the left, I have an alcohol on the second. If I start from the top, I also have an alcohol on the second. So the alcohols are a complete tie. So that means I'm going down to the double triple bond, which I don't have any of. So then I go to the end that's closest to the ethyl group. Well, if I start from this side, that will put the ethyl group on the 4th carbon. Had I started from the other end, that would have put the ethyl group on the 5th carbon. So that means I'm numbering from the left-hand side. Now name the parent chain. 8 is oct, and they're all singly bonded, so that's going to be octane. Now I need to list my groups. I start with my alkyl groups. I have an ethyl group, so that goes in front, and that ethyl is located on the 4th carbon. I also have 2 alcohols, so that's called diol, and that goes at the very end. And the alcohols are located on the 2nd and 7th carbon. So I will have to add in front of octane diol 2, 7. So this molecule is then called 4-ethyl 2,7-octane diol. So you have the rest of the class to work on the BR20 assignment. Next class, there will be a quiz on BR19 and BR20.